numerator is not 3 terms. It's not a trinomial. It's 2 terms. There's a minus in between. 49 is a perfect square. P squared is a perfect square. So we have the difference of perfect squares in the numerator. P plus 7 times P minus 7. Check it. P times P is P squared. Outside's negative 7P. Inside's positive 7P. Those cancel. 7 times negative 7, negative 49. Now, I don't like that denominator the way that it's written because it's not in standard form. And when I'm comparing my denominator to my numerator, it's really, really close. 7 minus P and P minus 7 are very, very close, but they are not exactly the same thing. Because if I change that order, the P was negative and the 7 is positive. So if I flip it around and put it in standard form, variables first, constants last, negative P plus 7. So it's not exactly P plus 7 and it's not exactly P minus 7. Well, remember that when your first term is negative, we want to factor out that negative. So let's factor out that negative 1 in the denominator. That leaves us with P minus 7. Check it again. Negative times P, negative P. Negative 1 times negative 7, positive 7. Now we have exactly the same factor. P minus 7 is in the numerator and in the denominator. But we can't forget about that negative 1 down there. It's very lonely. He doesn't just disappear. He's still there. But you're never going to see an answer choice that looks like that. What they're going to do is they're going to take this negative right here and they're going to slide it to the numerator. However, we're going to leave the parentheses around the P plus 7. Normally, we would drop that, but because we're moving that negative up there, we've got to keep the parentheses around the P plus 7. And I'll show you the graph here to show you why. And let's look at this. X squared, whoops, minus 49 over 7 minus x. Okay, and we said that the correct answer should look like this. Okay, it does. That's the exact same graph. What if we didn't put the parentheses? Okay, if you did not put the parentheses, if this is what your answer looked like, that is not 100% correct. It's close. You got the same shape, but it's not 100% correct. What if you just decided to leave the negative 1 out? Okay, that's obviously not the same graph. So that's not going to work there. There are ways to confirm whether you got it right or not. Now, that little box that says watch out, A minus B over B minus A, that is what we were looking at in this problem with P minus 7 over 7 minus P. That is always equal to negative 1. I wanted to show you why it was equal to negative 1 by factoring out that negative. So if you remember that and you see it pop up somewhere, you're certainly welcome to use that fact. I would rather you just kind of go through the process of factoring out the negative and trying to just memorize that idea. Okay, let's look at number 6. 12a cubed minus 3a. We've got a GCF. 12 and 3 are both divisible by 3. We've got a cubed and a, so we can pull out an a. 12 divided by 3 is 4. We had 3 a's. We pulled out 1 a, so we've still got 2 a's. Can't drop that minus, got to keep that minus. 3 divided by 3 is 1. And we pulled out the a, so we've got a minus 1. Distribute it back out to check. If you leave off that 1 at the end, you're not going to get that minus 3a that you had at the very beginning. In the denominator, 12 and 6 are divisible by 6. We've got a cubed and a squared, so they both at least have 2 a's, a squared. 12 divided by 6 is 2. We had 3 a's, we took out 2 of them, so we've got 1 left. Plus, 6 divided by 6, 1. We took out both the a's. We're not finished factoring. 4a squared minus 1 is the difference of perfect squares. So that is 2a plus 1 times 2a minus 1. You can always check it to multiply it back out to check. So we've got 2a plus 1, numerator and denominator. We've got 3 over 6. That's equal to 2 in the denominator, 1/2. 3 over 6 is 1/2. We've got an a in the numerator. We've got an a squared in the denominator. So that leaves us with an a to the first in the denominator. So what do we have left? We have 2a minus 1 in the numerator. In the denominator, we've got a 2, and we have an a. Now, I know it is really, really, really tempting to cancel those 2 a's right there. You cannot cancel those 2 a's, and here's why. If I replaced the 2a there with a number, let's say I've got 3. 3 minus 1 over 3. Okay, all I've done is taken the 2a and replaced it with a 3 in the top and in the bottom. Is that equal to negative 1? 3 minus 1 over 3, is that equal to negative 1? No. 3 minus 1 is 2. 2/3 is definitely not equal to negative 1. You can't cancel it there, so you cannot cancel it here. You can only cancel things when you are multiplying and you mark out the entire factor. If there's a plus or a minus, you cannot cancel. All right, let's do 7 and 8 as well because we need to review the idea of slip, divide, slide. Number 7, that numerator. All of those terms are even, so we can pull out a 2, divide all those terms by 2. Don't forget the plus 1 on the end. The denominator is also divisible by 2. Okay, so we got a factor of 3n squared plus 4n plus 1. When that first term is greater than 1, we use slip, divide, slide. I'm going to do it over here to the side just so my work doesn't get all jumbled up. So we slip the 3 to the end. 3 times 1 is 3. Then we factor. Pretty simple factoring problem here now. N times n is n squared. 3 times 1 is 3. Positive 3 plus 1 is positive 4. Divide. We slipped the 3, so we divide both of those by 3. So we've got n plus 1. 1 over 3 does not reduce, so we slide the 3 in front of that n. Check it. N times 3n, 3n squared. N times 1, n. 1 times 3n, 3n. N plus 3n is 4n. 1 times 1 is 1. So we factored that correctly. It doesn't matter what order you write those in. And you put them in the numerator there. In the denominator, that's the difference of perfect squares. That's n plus 1 times n minus 1. So what can we cancel? We can cancel those 2's. We can cancel the n plus 1. We are left with 3n plus 1 over n minus 1. Nothing else cancels. We can't do anything with those 1's. That's as far as we can go. You can graph it to confirm. All right, one more. Number 8. That numerator, don't like the order again. 45 minus 5w, that's not the way it's supposed to be. The variable is supposed to come first. It was negative though. That minus sign's got to go with it. Negative 5w plus 45. In the denominator, it'd be great if 3 was a GCF. It's not. 27 is not divisible by 3.